Precision and accuracy play a large role when you're trying to measure process variation. It's important to know the difference between the two because they are different, and that you have both precision and accuracy in your measurements so you can get a good handle on what your true variation actually is. So let's take a look at the difference between precision and accuracy, and then talk about how precision and accuracy of measurements can affect your process control. The definition of precision is that you have low variability in your data. So regardless of how accurate your data are or how close your data are to the true value, they're very close together and there's very little change between your measurements. Now you can have something that is accurate, or the average of all of your measurements is very, very close to the true value you actually have, but they can be imprecise. So let's take a look at that. Here we have data that are precise but not accurate. So all of these little shots here on this target are very close together. They're in a little cluster, but they're not anywhere near this center in the target here. If we look at these points here, they are accurate. If you were to take the average position of all of these points, they would end up pretty close to this center target here. So that's what we actually want. But they're not precise because we have such a large scatter in our points. So if we took this little clump here and then we moved it much closer to the center, that would be precise and accurate. If we took these large scattered points here and we moved it so that the center of these points was way off on the side here, that would not be precise or accurate. So when you're measuring data, you want to make sure that not only are you getting very repeatable measurements, but they're also accurate as well. And this is where calibration of your equipment comes in. The variation in your process can be affected by the precision and accuracy of your equipment. So looking at this temperature gauge here, it reads 146.76 degrees Celsius. That is great if it is actually that accurate. If it is only so accurate that it can tell you within plus or minus 5 degrees Celsius of what your process is doing reliably, then you should ignore basically everything past this 6 right here. So it's really telling you, hey, my process is somewhere around 150 degrees Celsius. I can't get any more accurate than that. A lot of people assume because this is a digital readout, especially when it's a digital readout, and I have 5 significant figures on there, all 5 significant figures must be correct. And if I want my process at 150 degrees C, oh no, it's at 146. I've got to do something about that. So they go and they turn up the temperature, where in reality this thing can only measure to 1 or 2 significant figures, and it's really telling you, yeah, your process is around 150. So because this equipment may not be very precise, you can end up introducing variation into your process that isn't actually there. It's the correction you make based on imprecise data. You also want to make sure that this gauge is reading accurately. So if it reads 146.7 degrees C, is it actually 146 degrees in your process, or is it 156? This introduces some measurement error, and you want to make sure that your gauges, whether they're for temperature or pressure or flow rate or weight, that they're reading the accurate amount that is being introduced into your process or that is coming out of your process. So if you're trying to fill, let's say, a bag of cereal to 10 ounces and your scale is reading 10 ounces, but you bring it to a different properly calibrated scale, and that scale is saying, there's only 9.5 ounces of cereal in each bag. Well, then you're underfilling your bags and you need to fix your scale on your process so that you don't get variation caused by inaccurate equipment. So how can we fix precision and accuracy in our process? How can we make sure that what these gauges are telling us are what's actually going on? Well, you can start by collecting more data. So the more data you have, the more confident that you can be that your measurements are precise by looking at the variation in your measurements. You also need to make sure that your equipment is properly calibrated. So taking a look at this temperature data here, we're making sure that the temperature we want to read, the T0, is actually what we are in fact reading. You need to maintain your equipment properly. So this includes regular calibrations, but it also includes making sure there's nothing crusted onto your temperature probe, that your temperature probe is not broken, that everything in your process is running the way it's supposed to, including your gauges. So when you do process maintenance, that's a good time to check all your thermocouples, check your gauges, make sure they're reading the way you want them to. And then finally, upgrading your equipment. Newer equipment is usually more precise and accurate, but not always. So that's something to look out for when, let's say, you're replacing a scale or a pressure gauge, that you want to make sure you're getting enough precision in your measurement to control your variation the way you want to, and that you're upgrading frequently enough that you don't have a lot of old, outdated, possibly hard to calibrate and maintain equipment in your process. So keeping your process clean, making sure you're getting enough data, and making sure you're maintaining and improving your process where needed can help you improve your precision and accuracy, and therefore get a good idea of the variation that is inherent to your process.